We're going to take a look at a little bit more practice with identifying information, trying to find graphs and other bits and pieces out of a parabola. And so we'll start off just quickly by using this parabola that's here on the right-hand side, and we're going to identify the AHK values and vertex and all that other good stuff in order to pull as much information as we can. So we'll start off by identifying the vertex, which is right up here. And so the vertex for this particular parabola is given to us at -5, 8. Okay, -5, +8. So -5, +8 is the vertex. And the great thing about the vertex is that it's also the HK value. So we know right off the bat, H is -5 and K is +8. Okay. This particular graph also has two nicely defined x-intercepts, one here at -7 and one here at -3. So the x-intercepts are happening at -7 and at -3. Now you could also choose to write this as -7, 0 and -3, 0. Okay, you don't necessarily have to. You can just leave it as -7 and -3, but this piece off to the right here is going to be useful for a little bit later on. Does this parabola have a minimum or maximum value? It's got a max value. There are no values of y that are higher than the vertex. So anytime that you have a parabola that opens down, it definitely has a maximum value. Okay, and the optimum value is the same as the k value. And so we know that the k value is +8. So the optimum value here is +8. So now what we need to do is we have to actually identify what the a value is. So the a value is going to be found in a couple of ways. First off, what we could do is we could use our step pattern. So we know that if you go over 1, 2, and then down 1, 2, 3, 4, 5, 6, 7, 8, you end up with a nice, clear, defined point. And when we talk about step pattern, we've got x, y1, and y2. Okay, and so we've talked about this over the course of this unit. The step pattern, you go over 1, you go over 2, you go over 3, and then your vertical change goes up 1, 4, 9. In this particular instance, if you move over 1, it's really hard to find a very clear definition of where it is. So here it actually goes down to -2. If you go down, if you move over 2 to the right from the vertex, it's -8. Okay, and so you actually have two potential spots that you could identify. You can get an a value from this because y2 is equal to y1 times a. We've talked about this often enough. And that means that the a value is equal to y2 divided by y1. So if you take any pair of y1, y2s, you can figure out what the a value is going to be. So let's say, for example, that I take the y2 of -8 and the y1 of 8. That's going to tell me that the a value is -2. Okay, and that is one way to figure out what the a value is going to be. There is a second way of finding out the a value, and that's by using algebra. Okay, and again, neither one is 100% the best way. One way is good for some, and one way is better for others. Okay, but if we want to find the a value, okay, again, what we need to know is, well, what's the vertex form of the equation for all parabolas? Okay, and it's given to you right there. And then you just start substituting in values that you know. And I'm going to choose, and for this to work, you have to have the coordinates of the vertex and one other clear point on your parabola. In this instance, we have two clear points. They're the x-coordinates, or sorry, the x-intercepts. So I'm going to use this particular x-intercept because it has an xy value. They both do, but I'm going to choose the one on the right just because I can. So I'm going to use 0 as my y value. My a value is what I'm looking for. My x value is -3. I know that my h value, if I substitute in -5 as my h value, put in there, and then my k value is +8. Okay, So now what I need to do is simplify and then isolate the a term. So 0 is equal to, in this case, negative 3 plus 5, because negative 1 times negative 5 is plus 5, all squared plus 8. So 0 is equal to a. So negative 3 plus 5 is equal to positive 2 squared plus 8. 0 is equal to, so 2 squared is 4. So a times 4, again, plus 8. Now there's nothing else for me to simplify here on the right-hand side of the equal sign, so what I need to do is start moving things over and isolating the a. So I'm going to actually subtract 8 from both sides. So that's going to leave me with negative 8 is equal to 4a. A4 or 4a is the same thing. I need to get a by itself, and right now it's being multiplied by 4, so I'm going to have to divide it by 4. I need to do that on both sides. So what ends up happening is that I find that, again, a equals negative 2, okay, which is exactly what I had the last time. Okay, so there's two different ways of figuring out what the a value is. Choose the one that works best for you. So now that you know what the a value is, we can actually figure out the equation for the entire parabola. So I'm going to just substitute in my a values into the formula that's given up here. Okay, so I know that the a value is negative 2. I know that the h value is going to be positive 5. Okay, and then I'm putting in plus 8. Okay, so now I've got my equation for the whole parabola. So I'll just write that here. EQN for the parabola. Okay. Now the problem is I got to figure out, well, what's the y-intercept? Okay, and the key thing about this is that the y-intercept always happens when the x value is 0. So at 0 and some value for y, that's where the x-intercept happens. And so what we do is we take the equation that we have, again, this is our equation for the whole parabola, and we substitute in the x term of 0. Okay, so that's our x term, and we're going to use that to figure out the unknown y. So I'm going to end up with y is equal to negative 2 times 0 plus 5 squared plus 8. So I'm going to get negative 2 times 5 squared plus 8. Y is equal to negative 2 times 25, because 5 squared is 25. Again, plus 8. Got to do the multiplication here. So I got negative 2 times 5, and that gives me negative 50 plus 8. And so the final answer for y is that it's negative 42, because negative 50 plus 8 is 42. So my y-intercept is actually 0, 42. Okay. So again, using the algebra, using some of the other tools and techniques of either the algebra or the step pattern will go a long way to helping us to solve various components of a parabola and their characteristics and what find out things that they can tell us. Okay, so good luck.